This demo is based on a vision language-based multi-channel video retrieval and summarization use case deployed and managed using RHEL Image Mode. The vision language models are AI systems that process both images and text simultaneously and bridge computer vision and natural language processing. The key usage models for this demo is the keyframe extraction with time and scene information, and also video summarization. The demo implements a video analytics streaming pipeline, which kind of captures the scene and the entities in the video and stored them as metadata in the RAG database. The user can interact with the system using a chatbot and can retrieve relevant information from the video, or can summarize the entire video or a part of the video based on timestamp. The hardware elements used in this demo is an Intel Core processor paired with an Intel Arc Battlemate GPU. The entire demo is running locally on the system, so that this adds extra security, as the data is secure and always on-prem and doesn't need to be going out to the cloud. For the software, the VLM and LLM AI models used for inferencing are optimized using OpenVINO and a RAG vector database, and it's used to extract accurate information from the video or either summarize the video. Moving on, this entire demo is deployed and managed using the RHEL Image Mode, which is an easier way of managing and deploying containers from edge to bare metal to cloud environments. And we use this to deploy our graphics drivers and deploy the workloads using Podman containers. So coming to the architecture of this demo, it consists of 5 microservices. The AI models are optimized using OpenVINO and running as Podman containers, and are either offloaded to Intel CPU or the Intel Arc discrete GPU. The Florence 2 base VLM generative AI model is used for the scene processing and image captioning. The YOLO 11N model does the entity detection, which kind of finds the objects in the video. The image captions are then extracted and stored in the embedding vectors in database along with the image and the timestamps. The user interacts with the Streamlit chatbot UI in natural language, which is served by the Llama 3.2 3 billion generative AI model for video retrieval and summarization. Dive a bit deeper to the data flow, we can see that the input video is split into images, and then each image is processed as either a scene and entity. The scene is focusing on the wider region of interest with wider information, and the entities are focusing on smaller region of interest like people and other elements in the video with less wider information. The fusion of this scene and entities gives us a very good accurate information in the retrieval and summarization of the video. The first use case is a keyframe extraction, where a user can query if a person is doing a certain activity or carrying a certain bag. They can interact with the user interface and get the exact image and the timestamp where the event occurred. The second use case is based on contextual information, where you can ask if a person is standing near a red building or if was there any event at 3 p.m. at that day, and that will be retrieved as an image. And the third use case is summarization of the video, where you can either summarize the entire video or based on a certain timestamp between certain hours of the day, you can summarize the entire video. To the demo itself, we start with showcasing the system where the demo is deployed. We showcase the drivers and then the microservices which are running on the system. Once we confirm the microservices are up and running, we go into the UI. The user then uploads the file in this case and selects the first use case, which is a keyframe extraction. The user then can query the system in natural language and then expect a response from the system as an image with a bounding box around the object. So the number of objects here are stored as the variable top k parameter, which is set as 1. We can change that variable to get multiple objects as well. Similarly, you can ask a next question where you can see if a person is carrying a pink bag. The same video can be queried multiple times with multiple prompts by the user, and then they can expect the exact answer from that video. Here we can see a person who is carrying a pink bag, but we just don't get the person's information. We get more contextual information of what the person is wearing, what kind of hair the person has, along with the pink bag. So we get the bounding box around that object. Now we'll go to the next use case, which is video summarization. Here we can ask to summarize the entire video, set the date and the timestamp between which we want to summarize the video. This gives the user flexibility to not wait for the entire video to summarize. We can also summarize a shorter clip. So here we can see we ask the system to summarize the video. It gives us contextual information of what the entire scene is about. It's like a typical morning scene in a bustling urban area. And then it gives descriptions of each object, gives the summary of events happening in the video. There are a plethora of edge AI use cases, right, from smart cities, safety, security, healthcare, finance, education, retail, manufacturing, robotics, etc. And each of these use cases have its own unique requirement. As we are fusing AI into the edge, we need an open AI edge approach to accelerate and adopt these use cases. And Intel's open edge approach and leadership at the edge accelerates and scale the AI and AI features with the advanced roadmaps and leveraging the XPU in the client. So Intel and Red Hat are collaborating together to integrate the latest drivers for NPU and bringing RHEL AI inferencing services to Intel Edge AI systems.